Here we go.
Step back.
Ready? In 3, 2, 1, 4. There we go.
Whoa! Whoa! Wow, that's great.
First, we're going to talk about factors that affect the rate of a reaction. The first possible factor is the concentration of reactants. This only affects reactions between aqueous or gaseous solutions. Solids and pure liquids have constant concentrations, making it so they aren't affected. The more molecules of reactants, the more particles collide and are able to react with each other. Therefore, typically the reaction rate increases as the concentration of reactants increases. Relating to Le Chatelier's principle, if pressure is increased and there are more moles of gas on the reactant side, the reaction will shift to the product side, causing an increase in the forward reaction rate. Increasing the temperature of a system increases the average kinetic energy of its particles. As the average kinetic energy increases, the particles move faster and collide more frequently per unit time and possess greater energy when they collide. Both of these factors increase the reaction rate. Hence, the reaction rate of virtually all reactions increases with increasing temperature. Conversely, the reaction rate of virtually all reactions decreases with decreasing temperature. When two reactants are in the same fluid phase, their particles collide more frequently than when one or both reactants are solid, or when they are in different fluids that do not mix. If the reactants are uniformly dispersed in a single homogeneous solution, then the number of collisions per unit time depends on concentration and temperature. If the reaction is heterogeneous, however, the reactants are in two different phases, and collisions between the reactants can occur only at interfaces between phases. The number of collisions between reactants per unit time is substantially reduced relative to the homogeneous case, and so is the reaction rate. The reaction rate of a heterogeneous reaction depends on the surface area of the more condensed phase. Automobile engines use surface area effects to increase reaction rates. Gasoline is injected into each cylinder where it combusts on ignition by a spark from the spark plug. The gasoline is injected in the form of microscopic droplets because in that form it has a much larger surface area and can burn much more rapidly than if it were fed into the cylinder as a stream.
An example of a catalyst in a chemical reaction is iron in the Haber process. This is used to mass-produce ammonia by nitrogen fixation. Iron is used as a catalyst to speed up the reaction. Another example is chlorofluorocarbon, or CFCs, that are found in the atmosphere. The chlorine present in the CFCs react with the ozone layer, which consists of O3 molecules to create chlorine monoxide, the intermediate product, and oxygen gas, or O2. Chlorine monoxide is unstable, so it reacts with other ozone molecules to create chlorine and oxygen gas as well. As you can see, the net equation turns ozone into oxygen gas. Also, the reaction and products remain the same. The catalyst chlorine does not go through a net chemical change, but speeds up the reaction of ozone into the oxygen gas. Here, a substrate comes together with an enzyme and they become attached to each other. The enzyme breaks down and separates the substrate to create the product. There are indicators on the substrates and enzymes that are able to precisely fit them together because they have to be like a lock and key. One example we found is the enzyme glucosidase breaking down the sugar maltose into glucose, a sugar the body can use.
Hello, puny humans. I am Dr. Meow II, the lion family. Today it is my burden to inform your simple minds about the biological wonder of yeast. Yeast, with one cell, is so incredible, while your trillions of cells are practically useless. Yeast, which belongs to the kingdom of fungi under the superkingdom or domain of eukarya, and allows you pathetic beings to ingest the fruits of nature. It contains the enzyme catalase, which breaks down sugars and releases carbon dioxide gas and alcohol. This allows you all to bake bread as the carbon dioxide gas rises and expands to fill its container. Thankfully, humanity was smart enough to make dough that can rise. But naturally, you would realize how to misuse yeast's power by placing the yeast species Saccharomyces cerevisiae, or brewer's yeast, in barley. You manage to make yourself even stupider. Ingesting the concoction you call alcohol makes your minds go flutter and you claim it to be fun. This is why cats are so much more superior. We use civilized entertainment to just yawn. I guarantee that this experience has been enriching to you. Anything intellectual is something a human has not learned.